I'm Heidi Henderson, the Fossil Huntress, and your host for BC's Fossil Bounty. Join in the exploration of the fascinating science of paleontology, that lens that examines ancient animals, plants, and ecosystems, from wee single-cell organisms to big and mighty dinosaurs.
Hi there, I'm Kay Lillico, and this is BC's Fossil Bounty. I am a Dinosaur Docent and Science Communicator at Dino Lab, Inc. I'd like to be chatting a little bit about how I dove into the field of paleontology without being a paleontologist myself.
Kay is a science communicator, but what is science communication? At its core, it's the practice of informing, educating, raising awareness. In the realm of paleontology, it's fueling the flames of curiosity, that sense of wonder about our ancient world.
I grew up in a very rural, small community in southern Alberta, so naturally I spent a lot of time out in the Rocky Mountains, exploring, lots of fishing and camping. I spent more time than you can imagine flipping over different rocks and looking for creatures. I'm quite fortunate with the fact that my family tried to encourage a love of learning and a love of science from quite a young age. We spent plenty of time traveling around, and every time we went somewhere new, my parents made a focus on trying to go to museums, to nature centers, to science centers, and I can attribute my love of science to that. I was always a child who was curious about the natural world. When I was about 9 years old, I took my very new little kitten Mango into the vet, and I met somebody named Dr. Ingrid Rosema. This was the start of a relationship that has continued into my late 20s. Dr. Rosema, she welcomed me into her clinic with open arms, and she tried to encourage my curiosity. Every single question that I asked, she made me feel as though I was important for asking those. She let me walk away with a sense of empowerment. I was fortunate enough that after a couple of years of going to this veterinarian, I had the chance to start volunteering for her, and eventually I even managed to start working for her for a couple of years. She is somebody who has molded me and shaped who I am as an individual because she gave me a strong and composed, science-driven woman to look up to. Every time I have a day at work or in my own personal life that feels a little bit shaky and I start to doubt myself, I think of her and I think of that support that she has provided. I think of the fact that even on our worst days, even on days where we feel as though we don't know what's going on or there is just a whirlwind of things to consider, you can always recognize that every mistake is a learning opportunity to improve upon and move forward. So I feel very fortunate to have been surrounded by science-driven women my entire life. I think one of the reasons that I felt confident enough to pursue paleontology without being a paleontologist myself is because of that background of support. I myself am a biologist. You do not need to have your roots in science to work within the field of paleontology, though. I do really want to stress that. Science is for everyone, paleontology is for absolutely everyone. Some of my coworkers, they have their background in the arts, or in carpentry, or photography. We even have one person who is a musician. It's important to see people coming from all sorts of different backgrounds to be able to create that different feeling within a science. As long as you have a passion for what you are pursuing, that's how you know you were headed in the right direction. You're never too old or too established in your career to start pursuing paleontology as well. About a year ago, I saw a job posting at Dino Lab Inc., and my first thoughts told me, wow, what an incredible opportunity. I would get to spend my day being surrounded by dinosaurs, being surrounded by fossils, as well as have the opportunity to share my excitement and to share my passion with a whole variety of different people coming in. My second thoughts told me that, perhaps you are not well adjusted for something like that. Perhaps this is something that is too far out of your scope. You're not a paleontologist, you are just somebody who is excited about the field of paleontology. And then my third thought said, well, you gotta start somewhere. Everyone's gotta start somewhere, and why can't it be me? I was fortunate enough to get that position and begin working with Dino Lab Inc. At Dino Lab, we do a couple different things. First and foremost, it is a fossil restoration lab, meaning that we receive a variety of different specimens, mostly vertebrates, the spined creatures, and what we do there is we remove the matrix, the rock and sediment that surrounds that bone. From there, we're able to prepare it and display it in museums and private collections across the world. In just the last couple of years, Dino Lab has opened their doors to the public. That's where my role comes in. My role at Dino Labs is as a science communicator and a dinosaur docent. You may be wondering what that terminology means. We are people who try and educate the public about the creatures that we are working to unearth and prepare for display in museums. Essentially, we try and take the hard science, the research done by paleontologists, we try and make it fun, we try and make it interesting, and we try and make it approachable. Whenever we're talking to different groups of people, we want them to know that this science is still for them. They deserve to be able to have an understanding. We bring people on guided educational tours where they get a little bit of a behind-the-scenes look at how museums can function. Because we are run privately, we let people have an actual touch and feel of a variety of different fossils that we have. Probably a ubiquitously wonderful moment that we see a lot of the time on our tours is people seeing our Triceratops Dozer for the very first time and asking if it's real. Dozer is very, very, very real. He's got his glorious face poking out of the rock, and after I've blabbed about him and talked about him, given his specifications, I welcome people to come on up and actually have a touch of them. That is where you see the light just come forward in their eyes, giving people the opportunity to have that Jurassic Park moment, so to speak, where you actually get to touch a creature that lived 68 million years ago. That's where you see the excitement come out. You see curiosity that is so ready and at the surface of children, but it is there in adults too. Paleontology is a science that welcomes people of all different demographics and ages. What I see more often than not is adults in particular are nervous to ask their questions. It takes them a little while to warm up and to feel comfortable asking all of the questions that maybe they've been holding on to since they were children obsessed with dinosaurs. Everyone has had a phase that drives them towards dinosaurs. Everyone has wanted to touch a dinosaur or see a T-Rex in the flesh, so to speak. By giving them the opportunity to have that sense of wonder, I think it makes science a lot more accessible for people.
We have a huge range of fossils in British Columbia. If we start on southern Vancouver Island in the Souk Formation, around Muir Creek, there's these lovely 25-million-year-old marine fauna that look remarkably similar to who lives there today. As we go up the island, we see both marine and terrestrial posits, plants, ammonites, turtles, mosasaurs. We have a huge range of fossils in BC, from the very young to the very old, plants, animals, arthropods, reptiles, ice age mammals, from ammonites to trilobites, to mighty marine reptiles and dinosaurs. We have them all.
When I am at work at Dino Lab, one of the things that lights me up is when people bring me a fossil and they ask what it is or what it could possibly be. More often than not, places that are now taken over by humans, used to harbor incredible amounts of diversity. British Columbia is home to a whole host of different invertebrate, spineless, and vertebrate creatures that have a spine. Vancouver Island only was formed about 55 million years ago, so before that, all of it would have been under the ocean. That means there are a whole host of marine invertebrate creatures that are ripe for the picking. When it comes to invertebrates, they tend to be a lot more speciose and diverse than vertebrates. This is exciting. You can just get outside, and where I live, you can find all sorts of different variety of ammonites and crinoids and barnacles. So you can have creatures that have spent 350 million years occupying the ocean, for example. One of these groups of creatures are the ammonites. These are relatives of modern-day octopus and squids. These creatures, they've got this glorious spiral shell shape, and they ranged in size from about a loony or toonie all the way up to about 9 feet in length. These creatures can be found everywhere that they used to be ocean. I would argue that they are one of the most successful animals to have ever existed on Earth's wonderful surface because of how long they have survived for and how much they have diversified within that amount of time. Any animal that can survive multiple mass extinction events, oh, they have definitely got something figured out. I would love to take a moment to tell you a bit about a couple fossils that light me up. One is a marine invertebrate called Anomalocaris. I know that generally in paleontology, people tend to fixate on the big megafauna, the dinosaurs, our T-Rex and Triceratops, Albertosaurus. They're fantastic and they deserve all of the recognition that they get. But so much of the diversity within paleontology is from creatures that do not have a backbone. Anomalocaris is one of those. It's a prehistoric arthropod, a relative of modern-day crustaceans, insects, and arachnids. And this creature here could get over a foot in length. A couple features that make it a little bit funky, a little bit gnarly, are these massive raptorial appendages, similar to what a praying mantis has, that would have been excellent for helping them forage for food. These would have been likely carnivorous creatures. It's such a bizarre looking little animal that when it was first discovered, the 3 different components that were discovered, which were the mouth, those raptorial appendages, and the trunk, were thought to be from 3 completely separate animals. I think it's quite the testament to life's ability to adapt and evolve. We have so many different creatures that even our imaginations would not be able to come up with. 500 million years ago, Anomalocaris was the apex predator of our ancient seas. I know we tend to not think of invertebrates, the spineless creatures, as the top of the food chain in many cases, but if you go back even to pre-dinosaur time, you are getting massive invertebrates who are the masters of their environment. I think it's important to remember that human history is only a tiny little blip in the entire focus of Earth's multi-billion year time frame. On top of having a whole host of different marine invertebrate fossils across beautiful BC, there are of course some creatures that are spined, the vertebrates. Now, one that comes to mind, a personal favorite of mine, is the ceratopsian, a relative of Triceratops, called the Pherosaurus, the iron lizard. Very evocative name. Now, the iron lizard, the Pherosaurus, is unique to BC as this specimen has only ever been found in BC. Nowhere else in the world can say that they have a Pherosaurus. As well as with dinosaur fossils, BC is home to marine life. Again, not just invertebrates. When it comes to marine life, there are a variety of different creatures that have evolved within the oceanic ecosystems to be top predators. What I would like to talk about is the marine reptiles, things like plesiosaurs and mosasaurs. These marine reptiles are not dinosaurs themselves. They would have existed at the same time though. They would have gone extinct at about 66 million years ago, and they would have been the rulers of the ocean. Some of these creatures are large enough that they could swallow me whole if they were to exist today. And along with the marine reptiles, there are also some turtles that have been found. Another fossil that is a little bit more recently discovered is an oviraptor, the egg thief. It's a very sexy little raptor, as I've heard it referred to before. This oviraptor here, what makes it unique is that it was found on a clutch of eggs. That in itself is not completely unheard of, but it's what we're able to decipher about the behavior of this group of creatures that makes it quite fascinating for me. So we're gonna jump forward and talk a tiny little bit about modern day dinosaurs, the birds, to give you a little bit of context as to why this fossil is special to me in particular. In birds today, in modern day dinosaurs, whenever a female is about to breed, she will begin to build a different kind of bone tissue inside some of her long bones, a tissue called medullary bone tissue. It looks completely different from the tissue that comprises the structural bone. When she creates this bone tissue, it allows her to build her eggs, build the calcium for the shell of the egg without breaking down, without causing any damage to the structural bone itself. That's why she has this medullary bone tissue. Every once in a while, a fossilized dinosaur will be found that has some of this medullary bone tissue. It is distinct enough from the rest of the bone tissue that you can tell beyond a shadow of a doubt that that was the medullary bone tissue. When you do find that on a dinosaur, you can say that that was a female. With dinosaurs, because the soft parts, the reproductive organs, generally do not fossilize, other than a few imprints here and there, it can be tricky to differentiate between male and female. That's why this medullary bone tissue is such a fascinating find. Whenever it is found, you can say conclusively that that would have been a female about to lay her eggs, or a female that had just laid her eggs. Every time you find a dinosaur that has an absence of this medullary bone tissue, unfortunately, it doesn't tell you too much at all. It could be a female that's out of the breeding season, it could be a younger female, an older female, or it could be a male. At that point, we really can't make any concrete evaluations as to the sex of that dinosaur. What makes this oviraptor that's on the clutch of eggs quite fascinating is that it has no medullary bone tissue at all within its body. So this gives us the indication that this individual could have actually been a male that was brooding on the eggs. That tells us a lot more about the behavior and the biology of these groups of animals. We know lots of modern day dinosaurs, lots of birds today, that do have both parents involved with brooding. In a couple of cases, there are even some where it's just the males that do the brooding and the parental care of the offspring. Being able to take this information, being able to see the behavior as well as the biology in a fossil, to me, that is gold. I think it's just so fascinating.
Paleontology is ever advancing. Advances in techniques and the use of technology like CT scans has enabled paleontologists to tease answers from rock and share with the world many of the secrets of our evolutionary history of life. Our prep techniques and ability to find, stabilize, remove and prep, and mount are changing day by day. Things like 3D printing let us share type specimens across the globe in real time.
When it comes to paleontology, it is a science that is constantly changing and constantly adapting. That's what I love so much about it. Throughout the rather torrid history of paleontology, there has been a wide variety of different developments, whether they be in the science side of things or technology-based. I would argue that 3D printing is one of the aspects that has launched paleontology forward decades in time because of the accessibility it creates for creating replicas of these creatures. A couple decades ago, if you had, let's say, a Tyrannosaurus Rex that was missing its entire left arm, if you wanted to display your Tyrannosaurus Rex, you would have to purchase a casted left arm of the Tyrannosaurus Rex. That is expensive. It is going to be very heavy. And when you think about how much variation there is going to be between individuals of that species, it complicates things. What if the cast that you purchase is too small for your dinosaur? Or what if it is too big or a little bit stouter? Today, with that exact same issue, if you are missing a full left arm from a Tyrannosaurus Rex, what you can do is you can use software to scan the entire right arm. You can composite all of those files from the scans. You can mirror all of those bones and you can actually just 3D print a perfect matched set of bones to complete that dinosaur. That changes the game. It also allows for a sharing of information that has never really been possible before in paleontology or in other fields. If there are a couple different museums that are working together on different research points, what they're able to do is they can send the files of those 3D print scans and they can share that information with no issues at all. It's much faster, much more efficient, and it's amazing to see that jump forward in technology within paleontology. I highly encourage anyone who's curious about the science of paleontology to get outside and go for a hike. Honestly, you would be surprised what you can find, whether you're looking or whether you are just going outside to explore nature. If you're ever curious about becoming a little bit more involved in paleontology, I highly encourage you to reach out to your local paleontological society to try and see what opportunities there are for learning or for volunteering or for pursuing a bit of a different education. You can also find resources online. You can take online courses. You can listen to lecture series about things that light you up and make you curious. Podcasts are so accessible. You can take them absolutely anywhere you would like. Citizen science is something that encourages people to become involved in sciences that might feel a little bit less approachable from the outside of things. Again, you do not have to be a scientist to be involved in science and make your mark on the world of science.
We've learned how Kay's passion for dinosaurs, those sexy little raptors and invertebrates, the wee beasties without backbones, led her to become a science communicator and pursue her dreams at Dino Lab Incorporated, and how you can too. We're all citizen scientists. Thank you for joining us on this week's episode of BC's Fossil Bounty. I'm Heidi Henderson, the Fossil Huntress.